It's a wild thought, right? What happens when our most advanced technologies start feeding on their own creations? We're in an age where AI is generating a huge chunk of all the new content on the internet. And that's created this really fascinating and frankly kind of terrifying paradox. It's a phenomenon that researcher Mahdi Hassan al-Haji calls AI cannibalism. And he gives us a wild look at how our own intelligent systems might just be eating themselves from the inside out.
So what exactly is this strange form of digital cannibalism? Well, it's all about what happens when AI models, which are built to learn from data, start learning from data that was created by other AIs.
Okay, so what does this actually look like in practice? Well, imagine an AI system just learning from itself over and over again. At first, everything seems fine, but pretty quickly, its understanding of the world starts to degrade. It gets distorted, and eventually, it just unravels into meaningless noise. And this isn't science fiction. It's a real, documented problem.
Yeah, this whole downward spiral actually has a technical name: model collapse. It's what happens when a model gets stuck in this bizarre feedback loop, learning only from its own synthetic AI-generated data. It starts to forget the little details of human reality, and its quality just tanks.
You know, the best way to get your head around this is with a super simple analogy. Imagine you take a photocopy of a really beautiful photograph. Okay, now take a photocopy of that copy, and then photocopy that one. With every single new generation, the image gets blurrier, it loses its sharpness, its color, until you can't even tell what the original picture was. That's exactly what's happening to the AI's knowledge.
Okay, so we've established there's a big problem here. But how do you actually measure this decay? How can you prove that an AI's mind is literally collapsing? This is where the researchers' work gets really innovative.
Instead of just, eyeballing the quality of the AI's output, al-Haji develops something called the Ainex law. The core idea here is to map out the AI's knowledge, almost like you're creating a 3D model of its mind. By treating its ideas and connections as a physical shape, you can then measure if that shape is shrinking or warping, or just losing its definition entirely.
And wow, the results are pretty startling. That blue line shows the volume of the AI's knowledge space. And as you can see, over just 20 generations of self-learning, it just plummets. The AI literally has fewer ideas. At the same time, that red line shows how far the AI's understanding has drifted from the original human data. That's the AI forgetting what reality looks like.
All right, let's break that down, because those terms are a little technical. We're looking at two key things here. Whole volume, that's basically a measure of the AI's creativity, the diversity of its ideas. You want this number to be big. Centroid drift, on the other hand, measures how much the AI's worldview has gotten twisted away from the human baseline. You want this number to be small. The graph we just saw shows the first one shrinking, while the second one just explodes.
And the actual numbers are just staggering. In the experiment, the AI saw a 66% reduction in its semantic diversity, its hull volume, in just 20 generations. That is a catastrophic loss of information.
So this brings us to the real million-dollar question here. Is the problem just that we're feeding AI bad data, its own recycled garbage, or is there something fundamentally broken with how we're building these systems in the first place?
And according to this research, it's not just the data. It points to a deep, core design flaw in most AI today, something the researcher calls the rigidity penalty.
So what is the rigidity penalty? Well, it all comes down to the fact that most AI models are static. They get trained and then their structure is basically frozen in place. This works great for predictable problems. But when you face it with the messy, chaotic, always changing nature of reality, their fixed structure just can't keep up. It can't adapt.
And you can see that problem so clearly right here, that complex, evolving shape, that's reality. The smooth, fixed red line is the traditional AI trying to understand it. And that massive empty space between them, that's the failure gap. That is all the nuance, all the complexity that the rigid AI is completely missing.
Okay, here's another way to think about it. Imagine you're trying to capture all the water in a flowing river, but the only tool you have is a solid square box. You'll catch some of the water for sure, but the river's just going to flow around it. The box can't change its shape to match the current. A rigid AI is that box. And reality, well, reality is the river.
So if the problem is rigidity, it stands to reason the solution has to be flexibility, right? And this is where the research gets really forward-thinking, proposing a totally new kind of AI.
The researcher proposes this radical new idea called the Ainex fluid architecture. And honestly, the name says it all.
Instead of a solid, fixed structure, this is an AI that's designed to be fluid, adaptive, and constantly changing its shape to match whatever problem it's trying to solve.
And just look at the difference. It's absolutely incredible. On the left, you see that traditional rigid AI again, with its huge failure gap. But on the right, you see the Ainex architecture, that green line. It doesn't just approximate reality, it physically molds itself to the exact shape of the problem. There's zero waste in space, and it captures 100% of the information.
So how on earth does it do this? Well, it basically flips the entire script on how AI sees data. Instead of data being this passive thing it processes, the Ainex architecture treats data as an active pressure that physically shapes it. It's all governed by a principle the researcher calls the Salmon equation, and you can think of it like the instinct that tells a salmon how to swim upstream against a powerful current. It lets the AI use the pressure of incoming data as a force for stability instead of being overwhelmed by it. And the end result is the state called homeostatic equilibrium, where the system is so perfectly adapted that its error rate just naturally drops towards zero.
Okay, so this is way more than just a clever engineering trick. This is a fundamental rethinking of what intelligence even is and how we should be trying to build it. And that, of course, has massive implications for the future.
And what this does is it completely reframes the whole race to build artificial general intelligence, or AGI. Maybe it isn't about who can build the biggest, most complex model with the most parameters. Maybe the true path forward is about building models that are topologically fluid, that can bend and reshape themselves whenever they see new information.
You know, the researcher puts it perfectly with this quote: "The future belongs to fluid, adaptive systems, which physically become the shape of the reality they observe." It's just such a powerful vision of what AI could become, not just a tool that analyzes reality, but one that actually mirrors it perfectly.
And that leaves us with one last, really provocative thought to chew on. For decades, the holy grail has been to build a single, final, super-intelligent AGI. But if this research is right, if true intelligence is defined by constant change and adaptation, does that mean such a final, static form of intelligence is even possible? Or is the constant evolution the whole point?